Hello, today we are looking at unit number 4. Unit number 4 of matter and materials. Unit number 4 of matter and materials, which is the last unit. Unit number 4 of matter and materials, which is the last unit for term 2. And we are going to look we are going to just get an introduction. We're going to look at metals, we are going to look at semi-metals, and we are going to look at non-metals. Okay, so now here they say that, let me take this up a little bit. So they say that for many years, scientists have tried to classify simple chemicals into some sort of order. These simple substances are called elements. Okay, so what is an element? An element is a pure substance that cannot be divided into simpler substances by chemical means. Please get the definition. An animal, 1, is a pure substance. Number 2, that cannot be divided into simpler substances. Number 3, by chemical means. That is the definition of the element. This classification helps us to understand better how these elements react. The Russian scientist Dmitry Mendeleev was the most successful at organizing the elements. In the 1860s, he developed the periodic table. He organized the elements according to the atomic masses. He realized that the elements with similar characteristics appeared at regular intervals. In other words, periodically. That is why he called it the periodic table. That is the order or the classification of some sort. So he called it the periodic table. On the periodic table, the horizontal rows are called periods, okay? And so if you go horizontally, it is periods, and the elements are arranged according to their masses, okay? Vertical rows are called groups. Elements are with similar properties appeared in same group, okay? So let's look at a periodic table. So this is our periodic table, and then the horizontal rows going this way, we call them periods. That's period number 1, that's period number 2, that period number 3. Okay, so those are periods horizontally, and they say the periods are arranged according to mass. So the mass is the bottom number, so the smaller one, it will be on the left. So it's 1. As we go to the other side, helium, the mass, I can't see the mass of helium, but it looks like 4. And then for lithium, it is 7. For beryllium, it is 9, the mass. So you see, as we go to the right, the mass increases. And then they say the vertical rows are called groups. So this is group 1, this is group 2, this is group 3, this is group 4, all the way group 17 and group 18. And they say now this way the elements are arranged according to their properties, which means in group 1, all the elements, they've got the same properties. Group 2, they have their properties. Group 9, they all have their own properties. So in each and every group, the elements have got same properties. So let's go back to our notes. I just wanted to explain that. So we are here. They say every element on the periodic table has its own name, symbol, atomic number, and position. So now let's look at the periodic table. They say it has got a name. So normally the one that I gave you, do I have it? I have another periodic table. It's not here, but under the name, under the symbol, it will be the name. So this H is the symbol, the name is hydrogen, and the number at the top is the atomic mass. Sorry, the atomic number. We look at this one, for example. The atomic number is 5, and the symbol is B, and the name is boron. Okay, and if you go further, the mass is 11. Okay, they show you, for example, with this one, the atomic number is 29, the symbol is Cu, and the mass is, atomic mass is 63.5, and the name is copper. Okay, the name is copper. All right, and they say each and every element has got a position. So hydrogen will always be here. You will not find hydrogen here. Hydrogen is here. This is its position. Same with a sulfur. Sulfur will always be here. Okay, you will never find it in any other place in the periodic table. Okay, and where are we? We've covered that part. We covered the name, symbol, atomic number, and position, and also we've added the atomic mass. Okay, so they say the periodic table can be divided into 3 main groups, which is metals, semi-metals, and non-metals. And so here we've learned about the groups. So let's come here. The metals are on the left hand side of the dividing line. Let's look clearly. Where is the dividing line? Is this the dividing line? Yes, this is the dividing line that they are talking about. You see this bold line? This is the dividing line. So anything on the left hand side of this dividing line, you see it start here. So left hand side of the dividing line, it is the metals. Okay, and this metals are on the left hand side of the dividing line. Non-metals are on the right hand side and above the dividing line. Okay, so non-metals are the dark ones. They say they are on the right hand side and above the dividing line. Okay, so we look at our dividing line. Above there is a metal. We look at our dividing line here on the right hand side. It cannot, let me see. Okay, we only skip the white parts. I will explain the white parts, but you see here the gray ones are non-metals. And then let's look at the last one, which is non-metals. Oh, sorry. The non-metals are on the right hand side and above the dividing line. Yes, we are only left with the semi-metals, which are the one shaded in white. They say semi-metals are also called metalloids. Just know that semi-metals, the white one, are metalloids. Okay, so these are the ones that we see around the dividing line. Okay, they are around the dividing line. Now let's continue with our periodic table. Okay, now we are on activity 11. You can do activity 11, and after activity 11, let's continue. Now we learn more about the metals. Metals are elements found on the left hand and the bottom of the dividing line on the periodic table. We saw that most of these are solids at room temperature. So metals are solid. Properties of metals, you need to know this. They are shiny, they reflect light well. They are malleable, which means they can be shaped or bent without breaking. Okay, they are ductile. They can be drawn into thin wires or knocked into thin sheets like your copper. Most metals are solid at room temperature except for mercury. Okay, only mercury is a liquid. They are good conductors of heat and electricity. Metals have high boiling and melting point. And examples of metals are sodium, iron, gold, and silver. We see here gears, nuts, and bolts. They are made out of metals. Okay, I won't go through that interesting facts. I'll go straight to page 6. You will do that exercise. Let's see, that is activity number 12. Let me see if you need to do this exercise. Yes, you need to do that exercise, activity number 12. And let's look at semi-metals. Semi-metals are on either side. Just 1 minute. Semi-metals are on either side of the dividing lines. You saw them, the white portion between the metals and non-metals. They display both metallic and non-metallic properties. Semi-metals are also called metalloids. What are the uses of semi-metals? The uses, for example, silicon is used in computers and solar panels. Germanium is used in circuit boards of computers and in solar panels. Arsenic is used in LED lights and solar panels. Tellurium is used in rewritable CDs and DVDs, solar panels, and circuit boards. Examples of semi-metals are boron, silicon, germanium, arsenic, and cerium. Let's see them again in the periodic table there. The semi-metals, these white ones, boron, silicon, germanium, arsenic, cerium, all these white ones. Okay, so now we know their uses. Let's continue. Am I moving too fast? Yes, I think I'm moving too fast. We are here on semi-metals and we have covered what they are and what is the other name for semi-metals, metalloids, and their uses. So now we can continue. Let's continue and go to non-metals. In page 205, nonmetals are a group of elements that occur on the right and the top of the periodic table. We saw them the dark gray. Most of the nonmetals are gases or solid at room temperature. Properties of nonmetals, you need to know this. Mainly gases or solid at room temperature with exception of bromine, which is a liquid. Have a range of different physical properties depending on their state at room temperature. Solids are brittle and dull, and they are poor conductors of heat and electricity. Graphite, which is carbon, does not conduct electricity. Examples of nonmetals are carbon, oxygen, sulfur, iodine, and nitrogen. Graphite and diamond are both forms of carbon as indicated in the photos. You will see this clearly in your textbook. This is a diamond and this is the graphite on the pencil. This brings us to the end of our lesson. So you can do the following activity 14 and exercise number 18. And that will take us to the end of unit number 4, which is the last unit of a term 2 on periodic table. Okay, I hope you have enjoyed your NS for term 2. Thank you.